Applications of WAVs in agriculture. Applications of WAVs in agriculture. Over the past few decades, unmanned aerial vehicles, WAVs, commonly referred to as drones, have gained widespread acceptance and use in various fields. One such field is agriculture, where drones They revolutionize the way farmers produce crops and manage their land. WAVs have enabled farmers to collect data faster, more accurately, and at a lower cost, leading to better decision-making and increased efficiency. In this article, we will explore some of the applications of drones in agriculture. Crop mapping and monitoring. One of the most significant advantages of using WAVs in agriculture is their ability to provide farmers with real-time, high-resolution images of their crops. These images can be used to create a 3D maps and models of farmland, which enable farmers to monitor crop growth and predict yields. With this information, farmers can take the necessary steps to address these problems before they result in significant crop losses. Precision agriculture. Precision agriculture refers to the use of advanced technology to optimize agricultural productivity and efficiency while minimizing environmental impact. WAVs play a significant role in precision agriculture by enabling farmers to collect and analyze data with unprecedented accuracy and detail. Similarly, drones can be used to analyze soil fertility, enabling farmers to apply fertilizers only where they are needed, while avoiding over-application and reducing nutrient runoff. Crop spraying. Drones equipped with spraying equipment can be used to apply pesticides, herbicides, and fertilizers to crops with precision, reducing waste and environmental impact. Water management. Water is a scarce resource in many parts of the world, and efficient water management is critical for agricultural sustainability. Drones equipped with thermal sensors can detect areas of water stress in crops, enabling farmers to adjust irrigation schedules and reduce water consumption. Drones can also be used to monitor and map water resources, such as lakes, rivers, and reservoirs, to assess water availability and plan future water management strategies. Livestock management. Drones can also be used for livestock management, enabling farmers to monitor their animals more efficiently and effectively. For example, drones can be used to track the location and movement of livestock, identify sick or injured animals, and monitor grazing patterns. This information can help farmers optimize their grazing management, reduce livestock stress, and avoid overgrazing. Challenges and considerations. While WAVs offer many benefits for farmers, their use is not without challenges and considerations. One significant concern is the ease with which drones can be used to invade privacy. Farmers must ensure that they comply with all relevant privacy laws and regulations and communicate with their neighbors and communities about their use of drones. Another challenge is the risk of data overload. Farmers must ensure that they have the necessary technical expertise and infrastructure to manage the large amounts of data generated by drones and extract useful insights from this data. This may require significant investment in hardware, software, and personnel, which can be a barrier to entry for some farmers. Finally, drones are not a panacea for all agricultural problems, and their use must be integrated into broader agricultural management strategies. Farmers must consider the social, economic, and environmental impacts of their use of drones and ensure that they align with their broader agricultural goals and values. As the agriculture sector continues to face challenges such as limited resources, changing climate patterns, and market pressure, the role of technology becomes more critical than ever. WAVs have already proved their worth in increasing farm productivity, improving sustainability, and reducing costs, and their applications are only expected to expand in the future. For example, with the development of artificial intelligence and machine learning algorithms, drones can be used to analyze and predict crop growth and yields with even greater accuracy. Similarly, drones can be used to monitor and manage the spread of invasive species, which can cause significant damage to crops and ecosystems. In summary, the use of WAVs in agriculture is a prime example of how technology can enhance human abilities and address complex challenges. The integration of WAVs in agriculture is a robust solution to the industry's shortcomings as they face significant resource and sustainability challenges. WAVs have revolutionized agriculture for T. He better by enhancing farming operations in multiple ways. With their ability to collect accurate, high-quality data, WAVs have helped farmers monitor crop growth, predict yields, analyze soil, water resources, and even monitor livestock. The benefits provided by WAVs to the agriculture industry are astounding, and the industry can expect this technology to continue expanding its applications in the future. As technology continues to evolve, WAVs, with their machine learning and artificial intelligence algorithms, can analyze data and predict crop growth and yields with even greater accuracy. The integration of other technologies, such as field robotics, weather sensors, and satellite imagery, will also work synergistically with drones to optimize farming operations in real time. To fully realize the benefits of WAVs in agriculture, it is crucial to address some of the challenges and considerations that arise when working with this technology. One of the main challenges is privacy concern while using drones. Farmers must ensure that they comply with the privacy laws and regulations in their countries and communicate clearly with their neighbors and communities to avoid privacy invasions. Another consideration is the potential data overload that WAVs can generate during their flights, which could be overwhelming for farmers. Farmers must have the necessary technical expertise and infrastructure, a structure to manage the vast amounts of data and extract relevant insights that help them make informed decisions. Lastly, while drones offer multiple benefits, they are not a panacea for all agricultural problems. Therefore, farmers must consider the economic, social, and environmental impacts relating to their use and ensure that their drone use aligns with their broader agricultural goals and values. The development and adoption of these technologies are crucial for the sustainability and growth of the agriculture sector. As mentioned earlier, WAVs provide farmers with real-time, high-resolution images and data that enable them to make better decisions regarding their farming operations. By using WAVs to map and monitor crops, farmers can optimize their use of resources and minimize waste, leading to increased productivity and profitability. Furthermore, the integration of WAVs in agriculture can lead to more sustainable and environmentally friendly farming practices. For instance, by using drones to analyze soil fertility, farmers can reduce nutrient runoff, leading to cleaner waterways and improve ecosystem health. The use of WAVs is not limited to traditional agriculture alone, it extends to other areas within the agriculture industry. The forestry industry, for example, can use WAVs to monitor tree health, detect insect infestations, and analyze disease spread. Additionally, the fishing industry can use drones to monitor ocean conditions, identify schools of fish, and detect illegal fishing activities. The future of agriculture lies in the integration of advanced technologies like drones. The potential of drones in agriculture is immense, and as technology evolves, drones are expected to become even more efficient and effective in their applications. The commercial adoption of drones in agriculture is still in its early stages, and there are numerous innovations and advancements to expect. As the industry continues to evolve, there will be a shift from merely providing real-time aerial data to directing the drone stacked on the data gathered. The use of drones for autonomous activities like crop spraying, monitoring, and data collection will become more common. This will improve the speed and accuracy with which the drones operate, making the technology even more valuable to the agriculture industry.